All right, folks, these are the solutions to projectile speed practice number 1. All right, I'll let you read this on your own. Soon as you see an angle, the first thing you're going to do is calculate how much of that is over, which is 2.78 cosine of 19, which is 2.63. It's more shallow probably than I've drawn. I didn't have a protractor. I didn't draw it to scale. And then V naught Y is 2.78 sine of 19 degrees, which is 0.905 meters per second. So it's mostly over, but a little bit up, which is going to increase its hang time a little bit more from if you'd launched it straight out. And then get out your aggressions, cross out the 2.78 so you don't accidentally put that in somewhere. All right, that is step 1, even though if the problem doesn't ask you to do that. And then question 1 says, find the horizontal, vertical, and total speed at a specific time. All right, so horizontal speed is a trick question. Horizontal speed is always 2.63. That's a constant. The vertical speed is changing. Vy is V naught Y minus 9.8 t. So again, would be really tempting to put that 2.78 in, but we're not going to do it because we've already set everything up and crossed that out. Minus 9.8 times 0.45, and you get negative 3.5. Okay, so it's headed over at 2.63, same as it ever was, headed down at 3.5. But we want the total speed as well, what the speedometer would read. And the total speed is the Pythagorean theorem. I will draw you a picture in a second. So it's the square root of 2.63 squared plus, in parentheses, minus 3.5 squared. So that's going to become a positive. What you get is the square root of 19.2, which is 4.38 meters per second. What that looks like visually is it's going over 2.63 and it's going down. So it's now going faster vertical because gravity sped it up, and gravity didn't do anything to the Vx. But the hypotenuse is the total speed because it's instantaneously going over and down at that rate. So this dark purple is 4.38. And we know it's on its way down. There's 2 ways you can justify it. The easiest is clearly that the vertical velocity is negative, right? That's just telling you that it's headed down. The other way to check your work is the initial speed was 2.78. It slowed down on the way up and it sped up on the way down. And since 4.38 is bigger than 2.78, it's not only on the way down, we know it is beyond where it started, right? Because it had a speed of 2.78 when it comes back to where it started. Because it lost speed at a rate of 9.8 on the way up, and then it regained it on the way back down. Okay, so this gives you a little bit more information. Well, no, you can look at this too. It was headed up at 0.905. It's headed down way faster than that. So we know it is definitely below where it started. Okay, calculate the minimum speed of the golf ball. That is really a logic question that I want you to know. The minimum speed, the lowest it can ever be, is just the horizontal when it has lost all of its vertical. So the minimum speed is, we already know it, 2.63 meters per second. It's never going to be less than that. Okay, and then if you wanted to prove it, that's when the Vy is 0. We'll find that time in a second. But the speed would be the square root of Vx squared plus Vy squared. The square root of 2.63 squared plus, 0 is 2.63, right? So clearly not a good use of your time, but I just want you to show you that the math works out as well. Okay, so what time does this occur? That occurs when Vy is 0. So Vy is my initial speed minus 9.8 t, because my velocity function is always linear. We want to set that equal to 0. It had an initial speed of 0.905 minus 9.8 t. We're going to subtract 905 from both sides. So you get negative 0.905 equals negative 9.8 t. And now we are going to divide both sides by 9.8 negative. And t equals, sorry, I forgot that this was part of it, 0.905 divided by 9.8. T equals 0.0923. So it happens really, really fast because the launch angle is so shallow. Okay, calculate the maximum speed. What time does this occur? So the maximum speed, we actually have to find the time first, because, so the minimum speed, we knew what it was. The maximum speed is right here, right before it hits the ground. So we need to find that time so we can calculate the numbers. So that is what we want, the time when it hits the ground. And so that means that I have no more vertical. You want to set y final equal to 0. All right, so I've hit the ground. I did have a head start of 0.85. I started at an altitude of 0.85. I was headed up at a very small rate, but it wasn't 0. And then the gravity is pulling me down at 9.8 meters per second. Okay, and then let's get out our calculators, do the quad. A is negative 9.8 over 2. B is 0.905. C is 0.85. And you get a time of negative 0.334 seconds and positive 0.519 seconds. Okay, let's just quickly go back to the picture. Again, your calculator doesn't know that this parabola kind of started here. We got a positive time, that's the keeper, and then the negative time would be as if you extended that parabola back, even though this axis isn't time. What that means is if you threw the golf ball from the ground and it headed up and it would pass the lab bench with a speed of 2.78 if it had been in the air for this amount of time. That's what that means, kind of going backwards in time. But clearly we're not going to use it. Okay, so we want the speed, and speed is 3 steps. First of all, recognizing that Vx is constant, calculating Vy, so we started, for some reason that small number is really bugging me. I don't know why. I'm sick of like putting the decimal first. All right, sorry. Okay, so we start out going this fast, upward. Gravity's going to quickly bring that to be 0 and then negative. So when it, just before it hits the ground, it's headed down with a speed of minus 4.18 in the vertical only. And then our total speed, let's see if we can fit this in here, is the square root of Vx squared plus Vy squared, which is the square root of 2.63 squared plus that negative parenthesis. So I'm just going to say, well, that, which is the square root of 24.39, which is about 5, right? Because it's about 25. So 4.94 meters per second. That's a 4. Let's just go back and check our work. About 5 meters per second. That makes sense because it started with a speed of 2.78. It slowed to a speed of 2.63, and then it sped up, and it hit with a speed of 4.94. Okay, that was, I tried to write a problem that was a little bit of everything conceptually about speed. All right, number 2. We want the speed, again, just before it hits. So we just did a question like that. So the first thing you want to do is go, okay, I need to break down my V naught X and V naught Y. There is no angle. So this is kind of a trick question once we've done both of them. V naught X is 1.2 and V naught Y is 0. It has no up or down. If you want a recipe, you could say 1.2 cosine of 0 because this angle is 0, and 1.2 sine of 0, and that would also give you 0 meters per second in the vertical. But I hope you don't need to do that. I hope you can just see. This is all horizontal. Okay. We want the speed just before striking the water. Okay, so your brain is going to want to go to a formula that has to do with speed first. So if you did that, you'd be like, okay, yay, speed. Speed is step 1, find Vx. Got that. Step 2, find Vy, but that's Vy here. We want Vy here. So it's going over at 1.2 and down at some speed we don't know. So, okay, I had a formula for that. Vy is V naught Y minus 9.8 T. What's my V naught Y? It is 0. I had no ups. Minus 9.8. And then you'll go, oh, I don't know T. All right, don't remember from first marking from the first unit and say, oh, I got to use don't know, don't care. Because we care about the time, right? We need the time. Then you're like, what have I not used? I haven't used the 10. You can set up your Sudoku if you want. You don't have to, but you certainly can. But you can say, okay, that's a height. And I hit the ground, so that means, or the water, that means I know where I am. So I'm going to use my position function because I know I'm going to use a velocity function up here. I hit the water, so I had no altitude. I started with an altitude of 10. Trick question, I had no ups for this particular problem, but I'm still on Earth. All right. Then we're ready to do quad. This is A, B is 0, C is 10. And you get plus or minus 1.43 seconds. Clearly, we want the positive time. Why is it plus or minus the same number? Because of the symmetry of this picture here. Because it was launched horizontally, you're at the peak. So if you move forward in time, you get 1.43 seconds. If you move backward in time, you get negative 1.43. Okay, but we want the positive time. Now we can go back up and we're ready to finish the speed calculations. So Vy just before it hits the ground or the water is 0 minus 9.8 times 1.43, which is minus 14, right? 10 meters is a lot. The atrium, if you were, don't do it. If you were, if you were to jump off the balcony, on the level of my office onto the back field, that was like 4.9, right? So that's why we're not going to do that. We're not going to jump off a 10-meter high building because you're going to hit with a speed of 14 meters per second, which is about 30 miles an hour. Okay, that's just still Vy. We got to find the speed, which is the square root of Vx squared plus Vy squared, the square root of 1.2 squared plus negative 14 squared, which is the square root of 197, which comes out to be 14.05. So just super quickly, the reason this is so close to the 14 is I was heading over at 1.2 because they just kind of threw themselves off the cliff. They mostly are just kind of jumping instead of like they're a person. They're kind of jumping off the cliff, but gravity had a whole lot of time to speed them up over a second. So this leg of the triangle is swamping the other leg. That's why the hypotenuse is pretty much the same as this leg because it's such, a shallow angle. All right, so hopefully all the math is starting to make sense to you. That was the impact speed with the water. All right, final question, which we did in class. So this is good practice if you want more practice or if you miss class. All right, so we have an angle and a speed. So the first thing you want to do is take 16 coastline 28, which is 14.13 meters per second, and 16 stop sign 28, which is 7.51 meters per second, and then cross out the 16. Okay. All right, so we took care of this. We took care of this. We haven't used the 16.8 meters. That is a horizontal position. So I like this question because I don't want people to always assume that the end of the projectile is when it hits the ground where y equals 0. Sometimes we care about what's happening after it's traveled a certain horizontal distance. So that means we're going to use our horizontal position function. It went 16.8 meters. It started at 0. It didn't have a head start. It started with a horizontal speed of 14.13. And there's no forces left and right. Gravity's only pulling it down. So that's 0. So divide both sides by 14.13. And you get a time of 1.19 seconds. That's here. But we want to know, hey, how hard is that a ball going to hit the goalie? And so we want this speed. So I'm liking this orange. So V naught X is same as it ever was, 14.13. V naught Y is started out going 7.51 meters per second, losing 9.8 meters per second for this much time. And you get that it is on its way down again. So none of these problems did things happen on the way up yet. Okay. That's not the total speed, though. We're almost done with this problem set. The total speed is going to be Vx squared plus Vy squared. And so that is the 14.13, that's a lot. It's about 28, that's about 30 miles an hour, plus minus 4.152 quantity squared gives you the square root of 216.9, which is 14.73 meters per second. So again, just super quick, one more visual of what that means is it is at that instant, let me get you a different color, headed over at 14.13 meters per second and headed down at 4.152. So mostly over because it's hasn't been, hang on. And then the hypotenuse is 14.73. So it started heading up at 7.51. So this is close-ish to the peak. Or maybe not close to, like this 4.152. It's had some time to gain speed on the way down, right? Because closer to the peak would be like a VY of negative whatever, negative 0.4 or something. Negative some small number. Anyway, I am babbling. That is how you do the problem. Again, so you have transitioned far enough along in your problem solving skills that you can see this is not a single plug and chug, right? It was a process, but it's always a similar process. It is breaking down your sine and cosine. Boom. Setting up the Sudoku if you want. Using the horizontal or the vertical to find the time. And then the speed is the 3 steps of get Vx, calculate Vy, little Pythagorean theorem. All right, people. Hoping this is making sense, and I will see you in class.